I'm very happy to be on this conference. Thank you for such opportunity. I would like to present you my short speech about implementation of phase ratio method and color ratio imagery to dawn mission images. My name is Valeriia Rychagova. I'm a first-year PhD student in Vienna Kharkiv National University. And let's go. Next slide, please. First of all, let's see what are the targets of dawn mission. It's the biggest object. It's two biggest objects of main belt of the solar system. It's asteroid 4 Vesta and dwarf planet Ceres. These objects are very interesting due to they are supposed to be only protoplanets that survived during early stages of solar system formation, and these objects could tell us many interesting things about the formation of solar system at all and formation of terrestrial planets. So this object has inner differentiation, and they are really much bigger than any other asteroids in the traditional terms. Next, please. To investigate these two objects, the dawn mission started. It started in 2007, and we can see that the Dawn spacecraft was equipped with three main instruments. It's framing camera, grant, and VIR. In our study, we used data from framing camera. It's multispectral imager that is equipped with one clear filter and 7 bandpass filters. Using images in different filters, we could characterize spectra of Vesta and Ceres. And for example, Vesta spectra is characterized by absorption band. It's absorption band of pyroxene, for example, we could analyze the depth of this band as well as the slope of spectra. Next, please. During the dawn mission, a huge amount of images was obtained, and it's really thousands and tens of thousands of images. These images were obtained under different light scattering geometry, and due to this fact, we could use not only color ratio imagery, but also a phase ratio method that we will discuss in the next slides, and also the main fact is that we have very good resolution for these two bodies. Its fact also allow us to use this method. Next, please. And what actually phase ratio method is? This method was developed to understand, to search for different structural changes on the moon surface. And actually it was developed in Kharkiv Institute. The main idea is that we have two different images obtained at different phase angles. And by dividing the signal in the pixels of these images, in the respective pixels, we could obtain the information about slope of phase curve, such a map of the slope of phase curve. And phase a function here in the formula, we can see f independence on alpha of a phase angle. Next, please. And such map of a slope of phase curve could tell us information about structural properties, because it strongly depends on such properties. After several steps of correction, we obtain a real map of the phase curve slope without the influence of topography, relief, or, for example, albedo. And with this image, we could work and derive some information. And the main rule that when we have alpha 2 greater than alpha 1, we could say that for this area, we have the steeper phase curve, and as a consequence, we have more rough surface. Next, please. On the surface of these two objects, Sirius and Vesta, we have some regions that we try to characterize, and for the series, it's occators, xaviosa, and oxocrators, as well as ahunamons. And for series, more informative is the underlined color ratio in the slide, because series spectra is more flat in comparison with Vesta, that has an absorption band. And for Vesta, it was important to obtain both ratios that characterize S slope of spectra, as well as its pyroxene band, depth of pyroxene band. Next, please. So here we could see example of images that we derived. It's very important to compare apparent albedo image, color ratio map, and phase ratio map to see the wall information, to characterize in different terms the researched region. And this is like an example. Xaviosa crater, as we have seen on the previous slide, it's a crater on the Ceres surface. Please, next. One of the interesting results was the results connecting with a huge amount of small craters with ejecta halo that we could see here in different regions. And this result was obtained both on Ceres and Vesta. But as we could see for Ceres, such halo connected with changes in slope spectra, but for Vesta, it's connected with variations in pyroxene band. So such bright ejecta on the color ratio map that we could see here point to more higher, maybe higher depths of the pyroxene band. Next, please. Valeriia crater region also is interesting due to some other features. For example, to the east of Valeriia, we could see a small crater with diameter approximately 400 meters that has very shallow pyroxene band, and also the same situation with the absorption band depths at 2 micrometers. And also the same situation we have with a linear feature near the south rim of Valeriia, and this feature is related to very rare type of collisions, glancing collision, and could be connected with impact at low angle or low velocity impacts. Next, please. The next feature is spots that demonstrate anomalous spectral slope, and as we could see, such spots are not recognizable on the color ratio map F3 to F4, but is very bright, and in terms of it's really recognizable on the color ratio map F8 to F3. And such feature also was recognized on the within other areas. It's Arisetolus region and Laeta crater region. Such spots have steep slope at 438 nanometers, and such behavior and location of such spots is strongly similar to behavior of light mantle that was recognized around Opia and Octavia craters. But we could say that such features are not connected, like it's not the same events, it's not the same phenomenon. And also very important that such spots are located on the rims of old degraded altered craters, or are not connected to any topography feature. Next, please. Also, using such color ratio imagery, we could see some slow processes like taluses and outcrops of material. We could see it for both Ceres and Vesta, and it's really useful to analyze such taluses in this way and analyze, for example, slope of spectra and depth absorption bands. Next, please. As we can see for Ceres, much maybe the most prominent feature is areas with smooth, with not rough surface. So as we can see, such areas have bright colors, lighter colors on the phase ratio maps, and it points to that such areas have smooth optical roughness. There is more smooth surfaces, but in some cases, like for the floor of Ocata crater, there is three small craters that have increased optical roughness, and it points that these craters are young, so it's young formation, and they have optical roughness different in comparison with the background of floor of Ocata crater. Next, please.
And we are running out of time, so let it be the last slide, and then to conclude us, please. Okay?
Okay. And the opposite situation we have for the Vesta. For the Vesta, the most prominent features connected with areas with increased optical roughness, and almost it's connected to the low albedo dark material. So increased optical roughness also connected with young formations, young craters, because we have disrupted higher layer of surface, and we could see it like increased optical roughness. So next, please. Also, we can see some dependence between number of new craters that overlap the ejecta of this craters on the picture. Dependence on how low is value of phase ratio. So the younger is the surface, the lower number of new craters we could see within this area. Next, please. And also we could see evidences of size-dependent separation within crater walls, both on Sirius and Vesta. And the last slide, its conclusions. So I could say that these methods are very interesting, and they also are effective for such bodies like Sirius and Vesta for the asteroids, and it was previously used only for Moon, Mercury, and for the comet Churyumova-Gerasimenko. So using such methods on different bodies with different evolution and surfaces, we could have some new insights and new interesting results, how it could, how many results and how many differences we could see using it on different bodies. So maybe that's all. Thank you a lot, and I'm glad to hear some questions.